In this lecture, we're going to compare two ways we have to initialize data in our constructors. We know about initializer lists in our constructors, but we also can do the same using member-wise copy initialization. Here is the class we're going to be using, the cylinder class we have grown to know and love. And we're going to see how we can use these two syntaxes. Here is how you can do member-wise assignment initialization. We have the constructor, we have the parameter list, and we're going to be doing our initialization in the body of the constructor here. We can also do the same using initializer lists, and the way to do this, you specify a column after your parameter lists, and you specify what you want to initialize your member variables with using the syntax here. So the initializers are basically going to be in these parentheses here, and this is going to work. We have seen this in the last lecture. So which one should you use between these two syntaxes? Well, I would prefer initializer lists because with member-wise copy, the object is really initialized in two steps. The first step is about object creation. And the object is going to be fully created, and then after that we're going to hit the body of the constructor and copy in the values for the member variables. So things are going to happen in two steps. And I am going to prove this in a minute when we hit Visual Studio Code, but note that with member-wise copy, things happen in two steps. And because of the copy we do in the body of the constructor, there is potential for unnecessary copies of data. Another thing that is special to member-wise copy is that the order of the member variables doesn't matter when you do member-wise copy initialization. You can put the base radius first, or you can put it second. It is always going to work. You're not going to have any problem related to the order of member variables. With initializer list, initialization is going to happen at real object creation. Your object is going to be created with the data that is specified in the parameters. So no need to do any copy in the body of the constructor, and this is a good thing. With initializer list, we're not going to be doing any copy in the body of the function, and the order of member variables matters. So you will have to initialize your objects in the order in which they were declared in your class definition. And we're going to see this in a minute when we hit Visual Studio Code. So there are differences between the two ways we have to initialize our member variables in our classes. And this is what we have here. Okay, seeing all these differences, I would recommend to always prefer initializer lists over member-wise copy initialization. For now, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in Visual Studio Code, and for this lecture, we're going to be reusing the code from the last lecture because we want to see the difference between member-wise copy initialization, which we are doing in this constructor here, and initializer list, which is what we are doing here. So let's uncomment the call for member-wise copy initialization, and we're going to comment initializer list here, because we really want to see that we are doing things in two steps when we do member-wise copy initialization. So what I am going to do is use the debugger to prove these things. I am going to put a breakpoint to the first line in the body of our constructor here, and then we're going to start and debug this program. We're going to go to the tab here that says Run. And I am going to minimize Visual Studio Code here because we want to see our terminal window when it pops up. And we're going to hit the green button here to start debugging. What we're going to do, we're going to hit this breakpoint here. And we're going to see that before we put in the data here, the object is already constructed. And what we really are doing here is just changing the member variables. So let's do that. We're going to hit the green button to start debugging. The compiler is going to build our program. The build is going to be good, and the executable is going to be passed to the debugger, and we're going to hit our breakpoint here. If you look in main, the code we have is to just set up an object of a cylinder, and this is going to call our constructor here, which has two parameters, and using the second parameter using the default value here, and we're going to hit our breakpoint in the body of our constructor here. Okay, so let's bring up our terminal so that we see that We don't really need this, but this is a habit for me now. Every time I am debugging, I need to see this window because you always want to see more information about your debug process. But for now, we have hit our breakpoint here. And what we want to see in this Run tab is information we have in our cylinder object. Because in our locals, we're going to have the data for that here. So let's look at what we have in here. You see that rad param is 5 and height param is 5 because that's what we passed in here. The parameters that were passed when we called the constructor here. But if we look at this and expand this, we're going to see that we already have the member variables for base radius and height, and the values are 1. And where is this 1 coming from? Well, it is coming from what we have in the header file. If you go back, you're going to see that our member variables at declaration, they are being initialized to 1 here. And this is the one we see in here. So if we go back to our CPP file, let's close this. We're going to see that if we execute this line number 7, we're going to see that the base radius in our object here, which is this object, you see that this pointer here, it's going to change to 5 because we just took rad param, which is 5, and assigned that to base radius. So let's do that. We're going to hit next. You see the base radius changes to 5. And if we hit next again, the height is going to change to 5. You're going to see that here. And now we have put the data in our member variables. But hopefully you see that things really happen in 2 steps. The object is going to be fully created, and then we're going to be given a window to change the data in the object. And we're going to change the member variables to whatever value we have in the parameters here. So things are going to happen in 2 steps. We're going to close our debugging session here because we are done with whatever we want. Let's close the terminal here. We're going to change and use our second constructor, which is using initializer lists. And we're going to see that by the time we hit the body of the constructor, the object is already constructed and it has the data we want, and we don't need to do any additional copies like we are doing here. So let's comment this out. So this is commented out. We are going to uncomment our initializer list constructor, and we're going to set up a breakpoint at line 19 here, which is going to be in the body of our constructor, which is using initializer lists. We are going to debug. We're going to go to our Run tab, and then we're going to run our debugging tools that use GCC. We're going to build with the GCC compiler. When the build is done, the executable is going to be passed to the GDB debugger, and we're going to hit our breakpoint here. You see we are at line 20 because line 19 is really not doing anything. But what we really want to see is the data we have in our object, which is this object here. Let's go in. We're going to see that the object is already constructed, but it has the data we want in. It has 5 and 5 for base radius and height. And we're not doing things in 2 steps now. When the constructor is called, it's going to use the data we have in our parameters, and it's going to use that to construct our object. And this is really cool. Things are happening in 1 steps. And this is better compared to what we had with our constructor that used member-wise copy initialization, because things were happening in 2 steps. There was a step to create the object using the data that we have initialized our object with in our class definition. And when the object was created, we was overriding that data with what we have in our parameters here. So we had 2 steps, but with initializer lists, we are doing things in 1 step, and this is really cool. So hopefully you can see that it is really advised to use initializer lists when you can, because they are going to avoid potential copies that you can do here. So suppose you have a member variable, which is an std string. It is possible, and you can do that. So when you have a member variable, which is an std string, the constructor is going to initialize your string empty, for example, if it is empty in your member variable here. And when we hit the body of the constructor, we're going to copy that string in. And you know that copying strings can be expensive because it's going to waste CPU cycles, and sometimes it even wastes memory. So you don't want that. You want to have the data in at object creation, and we can achieve that with initializer lists. This is really all I wanted you to see in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to learn about explicit constructors. Go ahead and finish up here and meet me there.